When we multiply fractions, we can use the multiplication rule as a over b times c over d, which you just multiply across ac times bd. Now, before we multiply across, what we can do is cross cancellation, where we cancel the like factors before we multiply it. It's a lot easier than working with larger numbers to reduce later. So 5 over 12 times 2/3. This is our first example. So before we multiply across, which would be 10 over 36, which we would have to then reduce, we are going to cross cancel. So any factor in the numerator that can reduce or cancel in the denominator, you can go ahead and do that. Or think about just rearranging your numerator or and denominator. 2 goes into 12 6 times. Or, for instance, this could be 2 12ths, which turn into 1/6. There's nothing else we can cancel. We cannot cancel the 3 and the 6 because they are both in the denominator. And when you have numbers in the denominator, you multiply. Same with the numerator. So 5 times 1 is 5. 6 times 3 is 18. Otherwise, we would have 10 over 36, and we would still have to divide by 2. 3/11 times 4/5. If we look at our numerators and denominators, there's nothing we can cancel, so we can multiply across and be finished. So if you can't cross cancel, or if you can't cancel at first and then you get your answer, you won't be able to reduce the fraction. So if you can't cancel, you can't reduce. If you can reduce here and you don't, then you will have to reduce here. So 3/10 times 4/15. Again, we will cross cancel or just cancel what we can. So 3/15. 3 goes into 15 5 times, or divide both numbers by 3. With 4 and 10, we will divide by 2. So 4 becomes a 2 and 10 becomes a 5. So 4/10 is actually 2/5. 2 times 1 is 2. 5 times 5 is 25. 6/7 times 14/6, or 14/9, sorry. 14/9. So 7 goes into 14 twice. I don't even really put a 1 there. I just know 7 cancels out all the way, and when something cancels completely, there's an automatic 1 there. 6/9 becomes 2/3 if you divide by 3. 2 times 2 is 4, 1 times 3 is 3. Now 4/3, yes, you can convert that to 1 and 1/3, but in algebra, 4/3 is an acceptable answer. If you were on the job or working on application problems and you are trying to figure out how long you have to cut a piece of wood, well, 4/3 is not very logical to use. Like, where is 4/3 on a tape measure? You would actually have to turn that into 1 and 1/3, so you can cut that 1 and 1/3 foot piece of wood. 4/3 is there, but we don't usually use 4/3 as a measuring component. So it depends on what you're in. Whether you are just working algebra, that's perfectly fine, or if you are doing an application problem, you would then have to convert over to a mixed number. And this will conclude multiplying fractions.